This section is all about ellipses. And if we look at the definition of an ellipse, it says that an ellipse is a collection of all points in a plane where the sum of the distances from the two fixed points called the foci is constant. So what that means is if I were to take this point and move it around the center of, or along the side of the ellipse, the distance from the point on the ellipse to each of the focal points is the sum of those distances are going to be the same. So if I say this is D1 and this is D2, if I add these distances together, it's going to be the same number if it comes from this point or maybe if it comes from this point over here. This distance and this distance over here will add up to the same distances as these two distances will be. So we have a couple things that we need to talk about here in terms of the vocabulary that we'll use. The center is going to be the H and K values. The foci, or foci, I guess we should call them, are 2 points on the inside of the ellipse. Then we have a major axis and a minor axis. So the major axis, in this case, it would be along this axis right here. It's the long side or the longest axis. And the minor axis is the short side or the shorter axis. So here we have an equation of an ellipse, and this is an ellipse in standard form. And we see that we have our x squared and y squared values over an a squared and a b squared value. The a value is coming from the longest side. The b value is coming from the shorter side. And the c value is coming from the foci. Okay, so we have this equation, and this is going to be something that we're going to use quite a bit to help us determine where our foci and vertices are going to be. But we need to remember that the major axis is always the long side. So here it looks like, you know, the major axis is along the x-axis here. And basically, if A is under the x squared, then we have a long ellipse. So it's going to be longer along the x-axis. And if A is under the y squared, then you're going to have a tall ellipse. So it's going to be more like this. Okay. So the A is always the long side, and if it is under the x squared, it's long, it's very wide. And if A is under the y squared, it's very tall. So we're going to just look at some examples and kind of dive right into what these formulas mean. So in example 1, it says to find an equation of an ellipse with the center at the origin. So this is our h and k value, which is 0, 0. And then we have one focus at 3, 0, and a vertex at -4, 0. So whenever we have this information, it's always good to get a picture, a visual of what it looks like. So I know that I have a center at the origin, and I have one focus at 3, 0, and I have a vertex at -4, 0. All right, so I have this information, and one thing about the foci and the vertices is they are the same distance away from the center. So if I have one foci that is 3 units to the right, the other one is going to be 3 units to the left. So that's going to be a foci. And the same with the vertice. If I have a vertice at 4 units to the left, I'm going to have another vertice at 4 units to the right. Okay, so another thing I noticed just from graphing this is that the foci and the vertices are along the x-axis. So our a, if we're looking at the equation, I have x squared over a squared, because a squared is going to be our longer number, plus y squared over b squared equals 1. That's our standard form of the equation. So if I were to look, the distance from the center to the vertice along the long axis is a. So I know that a is 4. And the distance from the center to the foci is a c value, and I know c is 3, just counting the spaces. And what I really need to know is where are my vertices along the short axes. So I'm going to use that formula that was on the other page, and that was b squared equals a squared minus c squared. Now, I want to find b squared, so I'm going to plug in a and c squared. So a squared is 16 minus c squared is 9, and this is going to give us 7. So b squared is 7, and b is going to be the square root of 7. So if I want to graph this, the square root of 7 is approximately, and if I think about this, 7 is in between perfect squares 4 and 9. So 7 is greater than 4 and it's less than 9. So the square root of 7 is going to have to be greater than 2 and less than 3. All right, and I think it's a little bit closer to 3 than it is 2. So we would say that this is about 2.6 or 2.7, a little over halfway between 2 and 3. So that goes on the short axes, the minor axes. So that'd be about right there. We're estimating, and these are our vertices. So if I were to draw my ellipse, just kind of sketch this in here. I'm going to connect all the vertices. My foci are always inside the ellipse. Okay, so here's my b value right here, my a value. And now we can write our equation, and our equation would be x squared over a squared, so that would be 16, plus y squared over b squared. Well, b squared we said here was 7, and that equals 1. Also, when we analyze our ellipses, we're looking for the center, and they already tell us it's at the origin. And usually we name all the vertices and all the foci, and actually we're going to do that in the next example where it says to analyze this equation. So looking at this, what I can tell here is because 25 is a bigger number, it's under x, so I'm going to have a long ellipse, and I know my a value is going to be 5 and my b value is going to be 3 because this is a squared and this is b squared. So just graphing what we know so far, I'm going to start at the center because I don't see any h and k values with x squared and y squared. We'll actually do that in the next lesson. Along the x-axis, my vertices are going to be 5 units away from the center. 1, 2, 3, 4, 5. There's a vertice, and on the opposite direction as well. Whoops, there's a vertice. And along the short axis, the y-axis, I'm going to have a vertice at 3 and one at -3. So I can actually sketch the ellipse right now without the foci there, even though we are going to put those there eventually. So when we analyze, we're going to find the center. So I know my center is at 0, 0. We're going to find the major axes. So my vertices along the major axes are at 4, 0 and -4, 0. And along the minor axes, they're at 0, 3 and 0, -3. Now let's find the foci. So I'm going to use the equation again, b squared equals a squared minus c squared, kind of a derivative of the Pythagorean theorem. And if I plug in my values, b squared is 9, and that equals a squared, which is 25, minus c squared. So if I'm thinking about this, I want to know 25 minus what number is 9. So I can subtract 25. So c squared is, or -c squared is going to equal negative 16. Sorry. And then if I multiply those by -1, c squared is 16, and I know that c is 4. And my c value is the distance from the center of the ellipse to the foci. So 1, 2, 3, 4 along the long axis. Here's a foci. 1, 2, 3, 4. Here we have one here. We also should name the coordinates of the foci. So this would be 4. Oops, I'm sorry. These up here should be 5. And this one should be 4, 0 and -4, 0. Getting ahead of myself here. All right, so that was another one where we took an ellipse, we graphed it, and identified the important parts. Another thing they might ask you is the length of the major axis. Now, if I think about it, from the center to the vertice, this was 5 units. So the length of the major axis is going to be 5 units here and 5 units here, which is 2 times A. which is going to be 2 times 5, which is 10. Then we have the length of the minor axis, is 2 times the b value, and if I count here, this is my b value, so I have 3 plus 3 is 6. Okay, so those are actually the lengths of the axes. All right, moving on to the next one. Now we're going to look at some ellipses that are tall. All right, so when the ellipses are tall, our long axis is going to be the y-axis. So the bigger number, a squared, is always going to be on the long side. So if it's a tall ellipse, it's going to be under the y squared. All right, so here it says to analyze the equation, and we have 9x squared plus y squared equals 9. This is not in the form that we have up here at the top. So the big thing here is I have a 1 at the end. I don't have a 1 here. So I could divide every part by 9. And this would give me x squared over 1 plus y squared over 9 equals 1. So just dividing by that constant term is likely going to eliminate any coefficients that we have with x and y, and it will put our a and b values underneath the x squared and y squareds. So I know that my a value, the long one, is 3. My b value, on my short axes, is 1. So if I look at this, do a little graph. A on the long axis, 3 units. 1, 2, 3. So here's a vertice and the other vertice. And on the short axes, on the x-axis, is 1. So just graphing now, we can see that this is a tall parabola. The long axis is the y-axis. And I know my a and b values, but I need to find my foci. So again, my foci comes from the c variable up here. So again, I'm going to do b squared equals a squared minus c squared. So b squared is 9, and that equals a squared, which is, b squared is 1, and that equals a squared, which is 9 minus c squared. So thinking about this, 9 minus what number is 1? That would be 8. So c squared is 8. And we could say that c is the square root of 8, or 2 square root of 2. So when I'm naming my vertices, the exact value is the square root of 8, but I can change it to a decimal. Well, first I would reduce it, so 2 square root of 2. This is the exact value, but I can change it to a decimal to help me graph. So I know the square root of 8 is close to the square root of 9. So this is going to be close to 3, but just under, like maybe 2.8-ish. All right, so my foci are going to be very close to my vertices. And when I am analyze the equation, again, we're looking for specific things like my center, which it's kind of confusing. We use a c for center, but we also use a c for the distance for the foci. But our center is at 0, 0. Our vertices are going to be at 0, 1, 2, 3. So 0, 3, 0, -3, and then we have over 1 up 0 and -1 up 0. My foci would have the coordinates of over 0 up 2 square root of 2. And then the other one would be over 0 down 2 square root of 2. So that would be negative. All right, so this last example 4, sorry, I'm looking for my notes. So this last example in number 4, it says to find an equation of the ellipse having the focus at 0, 2. So let's graph that and see what that looks like. We have a focus at over 0, up 2. And I have a vertice at 0, -3. And 0, 3. And it says to graph the equation. So I know that my A value is 3 units. So A is 3. And A squared would be 9. And my vertice, oh, that's not my A value. That is my A value, sorry. My C value is going to be the distance from the focus to the origin. So my C value is going to be 2. So C squared is 4. So if I'm looking for an equation, I have x squared plus y squared equals 1. And underneath these, the large side is on the y-axis, so that's going to be my a squared number. And I need to find my b squared number. And to do that, I'm going to use b squared equals a squared minus c squared. So I know a squared is 9 minus c squared is 4, so b squared is 5. So b squared is 5, and b squared is the number underneath the x squared, so I'm going to write a 5 under here, and my b value would be the square root of 5. And this is important to be able to graph on the x-axis where our vertices are. So the square root of 5 is a little bit bigger than 2, so maybe about 2.2. So here are my vertices here, and now I can draw the rest of my ellipse. Okay. All right, so that is all of what we're going to do at this point, and then we'll finish it up on the next lesson where we have ellipses that don't have a center at the origin. We're going to use some transformations with that.